This lecture, we will talk about roots and radicals. Before we do roots and radicals, let's review the things we have learned before. You know, 1 squared is 1, 2 squared is 4, 3 squared is 9, 10 squared is 100, 11 squared is 121 for this column. This is that given a number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, if you square it, you will get the number on the right hand side. Now the question is that given a number on the right hand side, are we able to find out the number on the left hand side? So this we will use the definition of square roots. 1 squared is 1, so go back, radical 1 is 1. From this number, go back to here. 2 squared is 4, then define. Radical 4 is 2, definition. 3 squared is 9, then define, definition. Radical 9, this number choose radical, is 3. 4 squared is 16, definition. Radical 16, from this number go back to 4. Okay? Then we know radical 100 should be 10, and radical 121 should be 11. And then we know more is that radical 225 should be 15 then. I didn't write here. Look, we know 1 squared is still 1, so we can put 1 square here. Since 1 squared is still 1 here. Now 4 can be written as 2 squared. So this tells us radical 2 squared is still 2. 9 is 3 squared. So radical 9 is 3, is radical 3 squared is 3. 16 is 4 squared. So radical 16 is 4, can be written as radical 4 squared is 4. 25, this number is 5 squared. So radical 25 is 5, can be written as radical 5 squared is 5. Similarly, radical 8 squared is 8. This basically says that any number squared, choose the radical, it goes back. So you will have a radical a squared is a. If we assume a is greater than 0. Okay? This property is very useful. We'll use this one later. Now, the above is about something squared, or then the definition of the square roots. Consider 1 cubed, that's 1 times 1 times 1 3 times is 1. Then we know cube root of 1 is 1. So cube root of 1 is 1. Radical 1 cubed is -1 times -1 times -1 3 times, then -1 choose the cube root is going to be -1. 2 cubed is 8, and then 2 cubed is 8, then cube roots of 8 is 2. 3 cubed is 27, then the cube root of 27 is 3. Definition, defined. 4 cubed is 64, then cube root of 64 should be 4. Okay? Or again, you can write 8 as 2 cubed. So then, cube root of 8 is 2 is the same thing we say cube root of 2 to the cube. 2 cubed is 2. Here, 27 is 3 cubed. So cube root of 27 is 3 can be written as cube root of 3 cubed is 3. And cube root of 64 is 4. 64 is 4 cubed. So cube root of 64 is 4 can be written as cube root of 4 cubed is 4. This property tells us that if 3 here index equals the 3 here exponent, the radicand inside this base can be simply poured out. You see 3 poured out and 4 poured out. As long as the index here equals the exponent. Okay, so this property is very useful. And here for square root, you can write 2 here. But for simplicity, for square root, we don't write. Okay, because square root used a lot. But for the cube root, fourth root, we have to write it. For example, 5 to the fourth is 5 times 5 times 5 times 5, 4 times, which is 625. Then the fourth root of 625 is 5. In general, this number n is called index. This sign is called radical sign. And inside the radical sign, this number is called radicand. The whole thing is called nth root of a. So fourth root of 625 is 5. Read as fourth root of 625 is 5. In your calculator, how do you calculate 5 to the fourth? 5 to the fourth is not 4 times 5. 5 to the fourth is not 20. 5 to the fourth can be calculated in your calculator by this sign. 5, arrow to the top, 4 equals 625. Then fourth root of 625 can be calculated as 625, this arrow to the top. Instead of write 4 there, you write 1/4 with the parentheses. You will get 5 here. Try this one, 2 cubed, you can be calculated as 2 arrow to the top, 3 equals 8. Then the cube root of 8, this one is cube root of 8 can be calculated in this way. So that's 8 arrow to the top and then 1/3 with parentheses. Don't forget the parentheses. You will have a 2. 5 cubed is 5, then arrow to the top, 3, 125. And then cube root of 125 can be calculated like 125, arrow to the top, and then parentheses 1/3, 1 divided by 3, equals 5. In your calculator, you can find out the value in this way. Radical 2 can be calculated as 2 arrow to the top, parentheses inside 1/2. You will have an approximate value 1.414. Try yourself. Radical 3 should be calculated as 3 arrow to the top, and then parentheses 1/2, then you will have a 1.732. Radical 4 can be calculated as 4 arrow to the top, parentheses, don't forget parentheses, inside the parentheses is 1/2. You know, radical 4 is 2. Radical 4 is 2. Radical 5 can be calculated as 5 arrow to the top, parentheses inside is 1/2. Don't forget again the parentheses. Then you will have a 2.236. So try this one yourself. Okay, now let's do some calculations. Note, radical 36 is 6. Okay, radical 36 is 6. The same way you can write radical 6 squared is 6, because 36 is 6 squared. Now we know radical 36 is 6. We also know radical 4 is 2. Radical 9 is 3. So together you have a 6. 2 times 3. But we also know 36 equals 4 times 9. That means radical 4 times 9 inside 4 times 9 equals radical 4 times radical 9, because they both are 6. Okay? Both equals 6. Okay? Now, this tells us that the product, choose the radical sign, equals radical value times another radical value. Now, in general, we have a radical AB, means A times B, equals radical A times radical B. Similarly, we know radical A over B equals radical A divided by radical B. Those two properties are used widely. Look at radical 45. 45 can be written as 5 times 9. And then by the property right here, that's radical 5, radical 9. Radical 9 we know is 3. Radical 5, you can just write radical 5. So radical 45 can be simplified as 3 times radical 5. Again, radical 9 equals 3 is right here. Now, try this one yourself. This one is radical 175. Remember, 175 can be written as 49 times 5, 25 times 7. 25 times 7. So then you know 5 can be out, radical 7. 7 stays inside the radical sign. Now, look at this example. This example says that radical A times radical 18A We know radical one value times radical another value equals the radical those two values times each other, a times b. So then we will have a 2 times 18, a times a is a squared. 2 times 18 is 36. We copy a squared down here and keep the radical sign. And then we use this property again. Radical 36 a squared is radical 36 times radical a squared by this property again. A is like over 36, b is like over a squared. Radical 36 is 6, not a problem at all. We use this twice. Radical a squared is a if a is greater than 0. Why? Look, this is the property we had before. So something, choose radical sign inside is something squared, that's a. So here is the same thing. Now try this one yourself. Radical 3b times radical 12b. So 3 times 12 is 36. Choose the radical, you have a 6. Radical b squared is just b, if b is greater than 0. So the final answer is 6b. Try yourself. Finish the middle steps. Now, radical 2 over 25, we need to use this property. So you do is that choose the radical respectively to numerator and denominator. We know radical 25 is 5, so upstairs we cannot do anything. So that's the final answer. Radical 5 over 5. In general, we don't want the denominator has the radical sign, okay? And then we just want to delete the radical sign in a proper way. Okay, this thing is called rationalize the denominator. Try this one yourself. Radical 5 over 81. So choose radical values for numerator and denominator separately. Radical 5, we cannot do anything because radical 5 is an irrational number, 2.236 and something more. So we keep radical 5. But we know radical 81 is just 9. 81, radical 81 is 9 here. Now, look at this one. This one, we use this property from this direction to here, from the right to the left. We know you choose the radical values for numerator and denominator separately. Actually, by this property from the right to the left, that's radical value numerator divided by denominator. 27 divided by 3, you have a 9. Radical 9 we know is 3. Radical 9 is 3. Try this one yourself. Radical 72 over radical 2. So use this property from this direction to the left. Then you will have radical 72 divided by 2, which is 36. So radical 36 is 6. Now, let's look at the last two, a little bit complicated example. Radical m to the 13th. 13 can be written as 12 plus 1. You can put 1 here if you want. Okay. So m to the first. So 12 plus 1 is 13. The reason I do this is because I know 12 equals 2 times 6. Okay, m to the 6th to the then squared. This is 2 times 6 is 12. Keep this m, okay, from here. Now we know, choose radical value to the product of this inside two values. By the property right here, we can choose the radical for this one, m to the 6th, then squared, times radical n. Okay, by the property again here. Now we know we can not do anything with radical m, so we put radical m here. And the radical m to the 6th, then squared, again we know that something radical a squared is a, and inside, you know, radical m to the 6th, then squared, we delete this square sign, then m to the 6th goes out. So m to the 6th is like our value a here. A here. Okay? A here. So this one, you want to read the one like this. Okay? Think about this one. Now try this one yourself. This one is radical n to the 17th. N to the 17th can be written as 16 plus 1. Okay? And then 16 divided by 2, we have 8. So n to the 8th. And then here we keep the radical n. Okay? Fill in out the middle steps, similarly like I did above. The last example. Try cube root of 40. Cube root of 40, you know 40 can be written as 8 times 5. By the similar property right here, okay, here the index is 2. If index is 3, it also works. So here we can separate 8 and 5, cube root of 8, cube root of 5. We know right here then we have a cube root of 5. We cannot do anything, so we just keep it as cube root of 5. Okay? Now, we know cube root of 8 is 2. Why? You see right here, 2 cubed is 8, then by definition, cube root of 8 is 2. So here, cube root of 8 is 2. Cube root of 5, we cannot do anything, we keep it. Okay, try this one yourself. That's cube root of 108. You know 108 can be written as 27 times 4. Then we know cube root of 27 is 3. And then 4, choose the cube root. We cannot do anything with that. So final answer is 3 times cube root of 4. Okay? And please review this lecture. There are many things inside here. And do some similar questions in your book. I'll see you in next lecture.